Hello, my name is Pranjal Pal and I am here to tell you about the important concepts of CN, computer networks. First of all, we will be understanding key network protocols and technologies. What we are going to study here? We are studying here to about important protocols and technology that present in our syllabus of computer networks. Let's see what we have deep dive into the next. Collision free versus limited connected protocols. We have studied different types of protocol as per the year past as the every generation has gone by. Some of the nice protocols are collision-free protocols. Transmissions are scheduled or pooled so collision do not occur. Example token ring, pooling schemes, predicted latency and fair access but need global coordination and can have a single point of scheduling failure. What does it imply that the transition should be not pooling each other. What can be understood by polling? Polling can be relying on single source for too much or for long time duration, so it can't be performed well, give us a good performance and have a stable performance. Limited connections protocols. Nodes content for the medium but use mechanism to detect or reduce collision. For example, CSMA-CD and simpler and decentralized performance degrades the under heavy load due to collisions and the retransmissions. As in the protocol, there is two major issues of collision and retransmission which are due to the heavy loads of the performance degradation by STM, SIDA and CD. So it can be reduced by limited concentration protocol. Practical trade-offs. Collision-free deterministic services, complexity in management and limited content, simpler hardware scalable with switches, modern lanes, and favors wasteful duplex design that removes the collision. In the current, we use the switches to handle our network worldwide, and we use wide area networks to fulfill our demands. Such of the protocols are used for the simplicity as well as the complexity of the current usage of time. Bit-oriented protocols STLC, and BSINC, LAB, and SLAB. SDLC Synchronized Data Link Control. IBM synchronizes the bits or oriented protocol frame delimited via flag, a bit shuffling for transparency polling response models and robust link level error control. IBM has introduced the SDLC synchronized data link control for frame delimiting. In the CN network, what we do when there are two network, we send the data, but data don't send directly through the bits. It converts into the frame blocks, and that transmitted and get decoded in the another system. Then it accepts the byte bit by bit. That was the synchronized data link control was given. HDLC, high level data link control. ISO stand for the generalization of SDLC for the point-to-point and the multi-point links supports the three model of normal and RM, synchronized balance mode, and ABM and the synchronized response mode. Now it is this upgradation of the SDLC in which we have the more point-to-point connection and the multi-point connection which increase are the data transferring rates and also the point sharing with the different types of modes. Each mode have their own usage in the amount of the area we are working in. They are differ in the field and the area of the scope. Biasing, binary synchronous communication. Early chapter oriented IBM protocol using the control characters and the frame synchronized and less effective than the model bit oriented schemas but historical important. It is used in the previous times in which the It it has the less transferring rate than the modern protocols, but it is necessary for because we have developed our technology from this also, so it is important for us to know about it and how its limitations. LAP B, link access procedures. LAP is a family derived from HDLC. LAP-B is the balance is used in X25 network for reliable acknowledgement deliver with the flow and the error control acknowledge and not acknowledge in retransmissions. As we know about the three handshake synchronization, in which we tell the two system that the first data pack has gone and the after it has been received, and then it gave the confirmation of the that he had received to the system that it came from. Similarly, the higher the SDLC has the subtypes in the family is just known as the lab and lab B, in which we uh, see the flow and the errors control acknowledgement by acknowledgement, not acknowledgement, and retransmissions. Protocol verification FMS and the pretty nets. Finite state machine modules. Finite state machine. First, hearing that name, we will be reminding of TOC, but it's different here. The model protocol endpoints adds the states and labeled transmission events useful for the verification of sequence. Example, the connection setup, sync sent is established, detecting deadlock and unreachable states with the improper timeouts. Assuming in a hub or a switch, we know that all devices are connected to it, and we have to make the internally working of hub and switch. They create a table of the devices connected to corresponding to their MAC addresses. So in this, we use the algorithm of the Floyd-Warshauer to determine the minimum cost we can find and between the nodes. So it is used for that, and simpler complex representation of deterministic variable well suited for the consequential and control logics. As we have learned in the TOC, the deterministic finite automata has very controlled logic in it. Nothing goes an overbound or a epsilon type of transition. We know what will be the all outcomes are predictable, and what will gonna happen is can be known in further times. Petri net models, bipartite graphs of places, transitions, tokens, capturing the concurrencies, synchronization, and resource usage. Stronger for analysis, parallel interactions, race conditions, and the buffer resource conflicts. Detect the livestocks, token starvation, and the concurrency hazards, and enable the reachability in the variation of analysis. Many of the terms we are familiar with as bipartite graph and transitions. Transition we have learned in the DEMS of that the it is a set of the action that follows. So in this also in the bipartite graph we see the livestock starvation and the concurrency and enable to reachability of variance. In the bipartite graph, we know that there shouldn't be a self loop and as well as the more than two paths of going to the different nodes by a single nodes. That we can determine by the bipartite graphs. So what it is used and the buffer and resource conflicts is similarly to our the problem of the operating system as the consumer starvation problem that we can be conflicted by the if a consumer starts eating before it gets stocked. What it is helpful for token starvation concurrency hazard. As we have learned about the concurrency hazard, there are multiple concurrency hazards are there which can be solved by these issues and can be detected as well. High speed LAN, fast Ethernet, Gigabyte and Ethernet and FTP. Fast Ethernet 100 base T, Gigabyte translate 1000 base T, FTP fiber distributed data interface. Each First of all, we all know the Ethernet. It is used for the internet transfer as a wired. So let's see its type. Fast Ethernet 100 BST is the 100 PS overhead trusted pair. Auto negotiation with 100 is common for campus and office area network. It's generally used for the office and campus network because 100 Mbps is more than sufficient for a student as well as a teacher and an office worker. Gigabyte Ethernet 1000 BST and the 1 Gbps using for 4 pairs of Cat5e and Cat6 supports the full dual-X switching and increase the frame rates for service and irrigation links. Now this is the upgraded version of the fast Ethernet of 100 BST. It is used where we need the high performance. And this we can see the frame rates of increasing in server and irrigation link. What is a frame rate? Is the frame rate is a generation of the frames in which we example of we are present in a website or we can take an example of game. In game every frame is generated by the seconds. If if our internet is strong enough, the number of frame will be generated will be high. Now let's go to the next, the FDDI, fiber distributed data interface, 100 Mbps on fiber in a dual ring topology, high reliability for the autonomic ring switching for the tolerance using the historical backbone links. Now, if I ask you if 10 people are using a single Wi-Fi, if all of their usage will be same? No, they will be different for their own self-required needs. So in this case, what does the FDI do this distributed the transfer? It sees which person needed how much internet it gets in that speed. So there is no backbone links or hanging off other persons. Performance matrices evaluating LAN throughout inputs using the input latencies and jitter, variance and delay, pocket loss and error rate and utilization. Measure under realistic traffic mixes and peak loads. Now, the most important IPv6 and IP versus IPv4 and IPv6 and the mobile IP. As we know that the IPv4 was firstly introduced and afterward the IPv6. And what we know about the IP is Internet Protocol, and each system has its own IP, and the every server has its own IP. But after the IPv6 come due to the limitations of the IPv4 in the number of IP addresses, and the more advanced version when the mobile are introduced, they need their own network to communicate. So the mobile IP has been introduced. Let's see more further details about the IPv each of these topics. IPv4 32-bit address of 4.3 and the widely spread N18 commonly to conserve the address header variable and due to options simpler routing but address scarcity. Heading fields include CITL protocols and header and such checksum. As because it was we, IPv6 introduced due to its high veracity of the addresses it can have. So we can see the IPv4 have the 32 bits, so it has less number. If the number of devices in a modern university are increased day by day, so we need a higher number of internet protocols to manage them. Where then the IPv6 has been introduced with the 128-bit address is the vast address space simplified fixed header built-in support for the extension header and the optional IPsec eliminates the widespread needs for NTA. Net improves auto configuration and multicasting handling. Nowadays we use the Netflix and Amazon Prime for our entertainment purposes, in which they use the video broadcast. So IPv6 is more efficient than the IPv4 in the terms of the number of hosts it can support, as well as the built-in support it gets about the broadband and the video customization and the video broadcast network. Mobile IP enabled a host to maintain a reachable IP connectivity while NGIC network, key elements of home agent, foreign agent, and the care of address and tuning encapsulation to move forward packets to the mobile nodes. All the we can see in our laptop, if we go to the settings of our Ethernet cable, we can see the options of IPv4 and IPv6. But if we go in our mobile and check for the Wi-Fi, we can see the number are not given in the IPv4, IPv6. It's a mobile IP. So it will be shown a little bit of different, but it has the same concept of using as the IPv4 and V6. IPv4 and V6 can be seen in the laptop both because of the we can use the IP before and after of the V6 coming. Both IP are generally used. Now TCP header format, field by field, ports and sequence. Source port, destination port 16 bits each. The sequence number of 32-bit ordered by bit stream position tracking. Acknowledgement and data offset. Acknowledgement number is a 32-bit and data offset header. In the acknowledgement indicated the next expected byte. Flag and windows. Control flag sync acknowledgement fine rest push urgent ease app. Windows size 16-bit flow control cadets. Checksum and options. 16-bit checksum for header plus data integrity. Operation vary mask sag window scaling timestamps and extend header length. Now we can see here the offsets in the size of the TCP header are made by the different fields. Each field are the port and sequence, acknowledgement, data offset, flag and window and checksum. They all are important for the TCP header format. Each of them have the potential uses, such as the port stores the source and destination port numbers. Acknowledgement stores the acknowledgement we will get from the three handshaking problem when the acknowledgement come from the other party of receiving the package we have sent. Flag and windows. Store about the controls. There are many control of synchronization, res, syncing, urgent. These are the controls we generally use. Sometimes we have the urgent message to send, so we can flag it in the we can in the write in the format of the TCP header. So it can seize the urgency and will transmit it faster than the other corresponding message are present in the stacks. Checksum and operation. Now the checksum and operation is the data integrity and timestamp. As we have learned about the timestamp protocol in DBMS, we know that the an older process will get the priority over the newest process. If I send a message on a WhatsApp, assuming that other person has his nets off, the all message will go on one tick. But whenever he turns on the net, he will get the message first, which I have typed the first as well. It won't get the latest message I have typed first. It will get the sequentially message. It is due to the timestamp because it stores the timing of the message who has come first and who will go first then. TCP establishes reliable order duplex system of stream using the bit sequence, acknowledgement retransmission times, and flow congestion controls algorithm. Example slow fast congestion avoidance. Slow fast is an algorithm introduced for the transmissions, which is very highly effective in the term of modern usage and can handle multiple and very reliable and order duplex streams. Let's move on further. Case study on HDLC and LCB in the real life world networks. Why HDLC and LCB persistent? Proven the mechanism for the reliable synchronized link frame delimiter arc acknowledgement retransmission sequence numbering and the balance operation worldwide used on the leased lines ISDN and the X.25 backbones. LAPC enforces strict acknowledgement and not acknowledgement in the retransmission or package networks. SDLC AMP simplifies peer-to-peer operation for few duplex links Operators benefit from the predictable behavior and the simple hardware implementations. Okay, as we have learned about the HDLC and LabB, we know that LabB is a family tree in the HDLC. So they have the similar usage, and we have also seen the name coming of X.25 backbones. So what it is? Let's think deeper in the frame limiter and the acknowledgement restraint. Frame limiter we have known about that the network sent in the mode of the frames sent package and frame by frame. Delimiter is nothing but a concept for limiting that frames, because if we send multiple frames or many frames, that can be lead to problem of finite counting. So we have to delimit it and use the frames logically so we doesn't end up in any kind of data losses. Now what the points I've mentioned, the LabB enforces the acknowledgement not acknowledgement through the packet network. Means the if we are using the LabB, then we will see that acknowledgement are the very necessary things, because if we don't get the acknowledgement, how do we know? But as real say there is not that much strict, we can send it in without getting the acknowledgement of it. So LTB enforces more strictly than the HDLC. SDLC is simplified as peer-to-peer operation or full duplex links. As we can say about let's talk about the Gmail. In Gmail, we send the mail to the other person, but we do not know that he had read the mail. So it's kind of peer-to-peer network. We can say Gmail is a peer-to-peer network. We do not get the acknowledgement from the other, but we have the send data. It is a confirmation. The both of this have the predictable behavior and simple hardware to implement. So it is both help us in the real life worlds. As we can see in the LabB, we can consider the example of WhatsApp, and the HDLC, we can consider the example of Gmail. In the WhatsApp, we will get the acknowledgement by the blue tick, and the HDLC, we didn't get the acknowledgement, but you know the data has been sent through mail. Why protocol verification prevents network failure? Step 1, model. Create FMS for model sequences in the perspective of concurrent transaction. Step 2, analyze. Use the reachability of liveliness in the deadlock check. Verify timeouts and retransmission behavior. Step 3, validate. They stimulate the representative workloads compared to accepted trace and redefine protocol transmission and time. Output. Reduce the production incidents and avoid of live logs and the deadlocks, and store confidence in the intern. So, for a protocol verification prevents a network failure, it has the multiple steps. Uh, So, step one will be the model, creating a FMS through control sequence and the network better for the concurrent intersection. So, as the step suggests, we have to create first model analysis validation, and the outcome will come afterwards. So as the model will be created which will control our flow and of the sequence and action we are performing, analysis will analyze that the action we are performing doesn't have any kind of live log or deadlock situation, so we can prevent that. And the validate will be the when all the networks and the path we have set are working properly and everything goes well, establish our validation, and the afterwards the outcome is generated, which builds the stronger confidence interpretability and reduce the for us a kind of a sample it would which will tell about the what could be happen if any kind of data loss is there, we will can see in the outcomes. Historical lessons, the early TCP and IP single control produces the costly bugs removal verification help to catch stable corners come before the rollback. Now validates will tell us about the any kind of the missing traces, and if if a trace is missing, that can be costly in the previous times and which can have a huge impact. So it doesn't have to roll back again and again. The validation step reduces our effort because it check after the analysis and all. So it tells us effectively what things are needed to be changed or where the trace is missing. So our building can be go as much simpler as it can. Now let's conclude this video by the summary and key takeaways. First, the access method. Collide-free deterministic scheduling, limited contamination and the decentralized but contestation sensitive. Link protocols, STLC, STLC and the Sync Lab B delivered framing of a consequence or for the dependable links. Verification, FNMs and the NITs make protocol behavior analysis essential for robust design. LAN and IP is the fast gigabyte and FDI meets the different needs, and IPv6 solve the address scarcity. Mobile supports the mobile via tuning. Transport TCP's header file and flags are central to reliable order delivered option enable modern performance tuning. So these are the keys we have discussed about the access method link protocol and verification LAN IP and transportation, in which we firstly see there are collisions. So we have your distributed scheduling, limited connection, we decentralize it, and the link protocols we have learned the four types of SDLC and know their uses and see how they are sequential and synchronizable. And the verification if they're SMS, FSMS and plus Pretty-NETs protocol, in which we see how the behavior is analyzable and robust in designs. In LAN and IP, we have discussed about the three Ethernet types in the first 100 base tree, 1000 base tree, and FTDI, which meets a different type of need of different types of peoples. Similarly, the IPv6 have solved the limitation of the IPv5, which have the fewer number of IP addresses now in the current world, which has more, so we will need it to expand it. And we discussed about the mobile IP. Now, similarly, transportation, and we will see that TCP has its format of storing the data, which consists of the four major blocks. So that's rounded about it. And so at this, I would like to say in the end that I hope you have understand this important topics, and any kind of queries will can be answered if you will write in comments and tell me about it, and I will be providing a notes link in the description. So please check it out and let's meet next time. Thank you.